Bismillahirrahmanirrahim. Welcome to the Structural Engineering Software Application class. This is lecture number 5 and it is about analysis of 2D frame structure in SAP 2000. Lecture outlines are objective of this particular lecture, introduction to the 2D frame structures, analysis of 2D frame structure in SAP 2000 by solving a very typical example, then some zooming and display option in SAP 2000 will be discussed, assignment and lab report format, and at the end some example are given for student practice and I will solve one example in SAP 2000 for student understanding. Now lecture objective. By the end of this lecture the student will be able to model and analyze different determinant and indeterminate 2D frame structure in SAP 2000. 2D frame structures. What is 2D frame? It is a combination of frame elements, beam and column. Keep in mind this thing, frame elements are interconnected through rigid joints, which transferring axial forces as well as movements. In figure, example of 2D frame is shown where element 1 and 3 is column and element 2 is beam. Right? Element 1 and 2 and element 2 and 3 are connected through rigid joints, which is labeled by 2 and 3. Right? From figure it is clear that both joints transferring axial forces, which is labeled by D4, D5, D7 and D8, and also transferring moments, which is labeled by D6 and D9. What is analysis of 2D frame structures? It is evaluation of structure for stresses, forces, bending moment caused by applied loads. The applied loads in the form of dead load, live, wind, earthquake and any other kind of loads. Right? On the basis of analysis, 2D frame structures are divided into determinate structures and indeterminate structures. Right? Determinate structures are analyzed by the use of basic equilibrium equation, which is given over here. Fine. And indeterminate structures are not capable of being analyzed by use of basic equilibrium equations. So different methods are available for analysis of indeterminate structures like moment distribution method, slope deflection method, flexibility method, stiffness method. But these methods involve a lot of calculation and mainly it is time consuming. As I mentioned different analysis method in the previous slide, and I told you that these methods take a lot of time. Nowadays, while using manual methods, a lot of finite element based tools and software are available for analysis purpose. Fine. And SAP 2000 is one of the structural analysis program and it can be used to create and analyze any structure rapidly while saving a lot of time and resources. Okay, now I will analyze a 2D frame example in SAP 2000 step by step. Right? The example details and different properties are given in this slide. Right? Like the dimension properties, the applied loads, the different cross section and material properties. Okay, now let's start modeling and analyzing 2D frame example in SAP 2000. Right? Analysis method in SAP 2000 is categorized into 3 phases: phase 1, phase 2 and phase 3. Fine. Phase 1 is called pre-processing phase, where different structure properties are defined and assigned. Second phase is related to analysis, where different load cases are set to run. Right? And third phase is called post processes phase, right, where different analysis result report are developed. Fine. Or to display different result like shear force, bending moment, reaction, deformation, etc. And this phase 2 is actually bridge between phase 1 and phase 3, right? Okay, phase 1 involved the following steps. First of all, you will create a new model and then define and edit grid lines. And these two steps are accessed from file menu, right? After defining models, other properties will be defined, such as define materials property, define member cross section for beam and column, then define load pattern, load cases, and load combination, right? And all the following different properties are accessed from define menus, right? Once you define the above property, the next step is to draw members, okay, where you will draw your model, your structure, okay, and this is accessed from draw menu. And finally, joints and load are assigned, okay, and these assignment are applied through assign menu. Okay, now I will apply the steps which I have discussed earlier on this example by solving it in SAP 2000. Okay, first step is to set up a new model, right? For this purpose, you will click on the file and then new model. So SAP 2000 templates menu will appear, and from this menu you can change the unit. Okay, from here you can apply different unit as per your requirement. Once new model is created, next step is to define and edit grid lines. Okay, for that you will click on the file, then new model, SAP 2000 templates. From here you will click on the grid only, right? When you click on the grid only, so this window will appear. From here you will define number of grid lines in x and y and z direction, and the corresponding spacing along x, y and z direction. Okay, now I will define a number of grid line for this 2D frame example. Okay, in this example, number of grid line in x direction are one grid line required in this location. This is grid line number 2 in the x direction, and this is grid line number 3. Similarly, number of grid line in the z direction are, this is one grid line in this direction, and this is second one. Fine. So it means that number of grid line in x direction are 3, and there is no need of grid line in y direction, and there is 2 grid line in the z direction. Okay, the grid spacing for the x direction is 10 feet, right? And there is no need of spacing in the y direction, and the grid spacing for the z direction is 10 feet. Fine. And this is the grid system developed in SAP 2000. Okay, how you will edit grid line? Just right click on the grid line and then select edit grid line option. Okay, so this menu will appear. From this menu, select modify and show system, right? So another menu will appear with the name define grid system data. Fine. From this menu you can edit grid data in x, y and z direction. Fine. If you want to change the spacing in x direction, just you can change the ordinate, right? The ordinate option you can change the values accordingly. Similarly, if you want to change the grid spacing in the z direction, you will change your ordinates accordingly. Okay, third step is to define material property. For this step, kindly refer to this lecture number 3. Next step is to define member section. In this step, I will define the frame element cross section, beam and column. Okay, for this purpose, just go to the define menu, then click on the frame section, then click on add new property, and from there click on the rectangular section. In the example, both sections are rectangular. Fine. For more detail about this step, please refer to lecture number 3. Here I will just discuss concrete reinforcement data form. Okay, when you just click on the concrete reinforcement, so reinforcement data form will open. Okay, this data form having different information like rebar materials and design type, concrete cover to longitudinal rebar center, and reinforcement or right for ductile beams. Okay, in today's class I will explain in very detail about the design type, fine, and little bit about the longitudinal bar and the confinement bar, and the rest of information will be discussed in the upcoming lecture inshallah. In the design type, SAP design two different type of cross section with the name column and beam. Okay, first I will discuss about the beam. Okay, SAP 2000 design beam for M3 design only. Okay, it means that the bending moment in third direction. Okay, what is the bending moment in third direction? For that I will consider a beam. For example, this is a beam and it is subjected to a transverse load. Fine, this transverse load causes a bending uh, actually in the z direction, and the direction of this bending moment is determined by the right hand rule. Fine, if you encircle, if you rotate your finger in the direction of bending moment, so the thumb will indicate you the direction of bending moment. Fine, in this case the direction of bending moment is in the z direction, and it is called the M3 direction, and the z direction is called M3 direction. Fine, now beam reinforcement data. This is a beam reinforcement detailing, right? And here is the longitudinal reinforcement and the transverse reinforcement. The longitudinal reinforcement is actually the main reinforcement. It is provided for the bending moment resistance. Fine, and here if you can see or hear longitudinal bar and longitudinal bar materials from this option, it means the main bar, right? And the ties, and we call the stirrups or the transverse reinforcement, it is used for the shear requirement, and it is mentioned by the confinement bar in SAP 2000. Okay, now coming toward defining member section column, right? When you click on the concrete reinforcement, and from there you will select the column design type, this one, right? In the reinforcement data form, the information will change accordingly. Now coming toward defining cross section for column. Okay, for that you will click on the column section, the design type. Okay, and when you click on, when you check the column in the design type, the input information in the reinforcement data form change accordingly. Okay, you can see the different information for column and beam are different, right? In order to understand the different terminology given in this form, first of all I will explain different types of column with respect to load application and responses, and then I will discuss about design of column, right? In SAP 2000, column is designed for P, M2 and M3. Let's discuss what is P, M2 and M3. Okay, with respect to load and responses, column is divided into three types. Okay, type 1 column is axially loaded column, where axially loaded column is applied at centroid, right? And this column is designed for P load only. Fine. And the second type of column is loaded with uniaxial eccentricity. Okay, and this column is called uniaxial loaded column, where the load is applied eccentrically either in x direction or in the y direction, and this column is subjected to p load and movement in one direction. It might be in two direction or three direction. And type 3 column is the column loaded with the biaxial eccentricity, right, where the load is applied eccentrically along x and y direction. Fine. And this type of column is subjected to the axially loaded P and two bending moment, and both in the direction of M2 or M3. Fine. And here you can see this is the load. It is applied eccentrically at centroid, and here the load is applied eccentrically along x direction, and this is the load applied eccentrically along y and x direction. Fine. And this is the column which is subjected to p load, mx and my, and it is biaxially loaded column. Fine. And these bending moment mx and my will either due to eccentricity of loading, or it might be because of unequal bending moment transfer from beam placed on this column. Now column design. Uniaxial and biaxial column is designed based on PM interaction diagram. It is a diagram between axial forces and bending moment, and it is actually the column capacity diagram, right? This diagram is developed for specific column section. Let's suppose this PM interaction diagram is for the column this one, and it is a column having cross section 12 by 12 and steel are 6 number 6 bar. In the diagram, the P naught or Pn point is for the column which is purely subjected to the axial compression force, right? And there is no bending moment demand on column. Beyond this point, the axial carrying capacity decrease because of bending moment demand on the column. Till this point, the column is compression control, and the column will fail because of crushing, right? Now beyond this point, the bending moment is dominated over axial forces, axial compression force, and it is called tension control section, and this section of the column failed because of steel yield, right? And finally at this location there is no axial forces, and the column is purely subjected to bending moment. Now for example, I want to check either this column will work for the demand of P1 and M1. So what you will do, you just locate this P1 and M1 point on this diagram. This column, the point shown on this diagram is outside the curve, so it means that this demand will not be safe against this column. Okay, the column will be not safe against this P1 and M2. Let's suppose there is another demand of P2 and M2. So again locate this P2 and M2 in this PM interaction diagram. So this is inside the curve. It means that this column will be safe against P2 and M2. We are in position to discuss different terminology given in the reinforcement data form for column, right? First of all, the reinforcement configuration. So reinforcement configuration is either rectangular or circular, right? So in the figure, this is the rectangular configuration of reinforcement, and the red dot shows the main reinforcement, and the configuration of these reinforcement are rectangular. Fine. these main bar are enclosed by a confinement bar, either in form of ties or spiral. Fine. Now longitudinal bar rectangular configuration. These are the different information which is also required in this form. So clear cover for confinement bar. It is actually the distance from the edge of the concrete to the centroid of confinement bar, and the number of longitudinal bar along 3 direction face, and it is actually the number of bar parallel to the local 3 axis of the section and including the corner bar, right? And actually this is the third direction, and parallel to this 3 direction, number of bar at face is this one, right? Similarly, the number of longitudinal bar along 2 face direction, it is along 2 face direction, this is along 2 face, this is 2 face, and parallel to this 2 face is this one, right? In both faces the number of longitudinal bar are 3. Then the longitudinal bar size, it is number 8, and you know that what is the size of longitudinal bar. If a size of longitudinal bar is the number 9, it means that the diameter of this bar is 9 by 8 inches, right? Now confinement bar. Okay, the confinement bar, as I told earlier, that it is actually the ties or spiral. It encloses the main reinforcement, right? The first thing in the confinement bar are the confinement bar size. It is entered over here. Then longitudinal spacing of the confinement bar. What is longitudinal spacing of confinement bar? It is the distance between these two confinement bar, which is actually the tie, right? Then number of confinement bar in the third direction and number of confinement bar in the 2 direction. What is this? This is the number of confinement bar, reinforcement bar, including the corner rebar on the two faces of the column that are parallel to the local 2 axis of the section. What it means? Actually in this diagram, these are the 2 confinement bar in the top face, right? And it is parallel to the 2 direction. Similarly, for the confinement bar in the third direction, and these are the confinement bar in the third direction. In both direction, the confinement bar are 2. Now reinforcement configuration in the circular format, right? And this is the reinforcement configuration in the circular format, where the longitudinal bar is provided in the circle form, right? And instead of tie in the confinement bar, these main reinforcement in the circular format is tie by spiral, right? And the other information for the circular configuration are clear cover for the confinement bar and number of longitudinal bars and longitudinal bar size, right? In this configuration, you just required to enter the number of longitudinal bar, okay? And in the confinement bar, you will just enter the confinement bar size and longitudinal spacing of confinement bar. As discussed in the previous slide, this is the spacing between the spiral, right? Now come toward check and design. First option is reinforcement to be checked, and the second option is reinforcement to be designed. What do you mean by reinforcement to be checked? If the reinforcement is to be checked, all the information the reinforcement data form is used, right? If the reinforcement is to be designed, all the information in the reinforcement data form is used except the bar size, which is ignored, and the total required steel area is calculated. The reinforcement configuration, longitudinal rebar data and cover to rebar are used. Okay, it means when you check the reinforcement to be designed, so here they will ignore just the size of bar, and rest of the information will be same. Okay, this is all about step 4 in the phase 1. Now move toward step 5, 6 and 7. Okay, I have already discussed step 5, 6 and 7 in lecture number 3, so please refer to lecture number 3 for detail. Now let's move toward Step 8 in the phase 1, and this is phase is about draw the frame elements. Okay, for that you will just click on the draw menu, then go to draw frame element in cable. So a window will appear. From this window you will select the section which you want to draw. If you want to draw beam, so select beam, and if you want to draw a column, select column. In step 9 you will assign different joints condition. Okay, where you will apply support condition. How you will apply support condition? For this purpose, select joint where you want to assign restraint, then go to assign menu, then select joint and then restraint. Okay, from this menu you can assign your fixed support, hinge support and roller support. Okay, once you apply the different support, so this is appeared in the shape like this. Now step 10 is to assign loads. In this step you can assign different loads like point load, uniform distributed load and uniform varying load. For more detail you can refer to the lecture number 3, but I will discuss this step as well in this lecture. Okay, if you want to assign a joint load at particular point, for that you will just click on that particular joint, right, then go to assign menu, then select point load or joint load. Okay, so this menu will appear, and from this menu you can apply a joint load at that location. Okay, so in our example we want to apply a joint load in the z direction. Okay, for opposite direction, opposite to the z direction, you will just put negative sign. Fine, this is the example. We have applied 150 kip load in the z negative z direction, right? Okay, there is some options given in this menu, right? The options are add to existing load, replace existing load or delete existing load. From this option you can add, delete and replace existing load if you want, right? But this option is applicable to a particular load pattern. Similarly, you can apply a uniform distributed load. In our example, we want to apply a uniform distributed load at this column. So what you will do, you just select this frame element, right, then go to assign, then click on the uniform distributed load. So this frame distributed load menu will appear. From here, uniform load, you can just put 20 kip load, 20 kip per foot load, and click on OK. So this load will be applied in this direction, but keep in mind this direction of the load is X. Okay, so you will select this X direction. Similarly, if you want to apply a different loading, right, so you can also apply. For example, if you want to apply this kind of load, so for that you will select this portion only and then go to assign, select distributed load and apply 12 kip per foot load in this direction. Fine. Similarly, if you want to apply a point load at this location, so you just select this joint and apply 10 kip load in X direction. Fine. Okay, we can also apply uniformly varying load. For example, if you want to draw this triangular load in SAP, so how you can draw this? Okay, you can draw this load from frame distributed load option. From this menu there is an option with name trapezoidal load. From this trapezoidal load option you can draw this particular load. Okay, how you will draw this load? So for this load you require 2 points, this one and the second point. Okay, so what you will do, you will enter the distance and load for these 2 points. For this first point, it is located at 0 location, right? So the distance of this point will be 0 and the load magnitude at this point is 10 value, right? Similarly, the second point is this one. What is the distance of this point from this location? It is 12, right? And the load magnitude at this location is 0. right? You will keep the 3 and 4.00, so this load will be applied. Okay, this is all about phase 1. Now coming toward phase 2. Okay, phase 2 is about run analysis. How you will analyze or run analysis? You will just go to the analyze menu, then click on the run analysis or press F5. In this phase you will set load cases to run. Okay, when you just click on run analysis, so this window will appear. From this menu you can set your different load cases you want to run. Okay, when you set your load cases, then just click on the run now, so analysis will start. Okay, once the analysis completed, now we are in phase 3. Okay, in this phase you can check the analysis result like shear force, bending moment, and different reactions and deformations, right? In order to check the different results, you will just go to the display menu. Fine, then click on the show forces and stresses, then go to the frame cables or joints, right? So when you just click on the frame or oblique cables, so this menu will appear. From here you can check different results, like you can see the moment 33, shear force 22, axial forces, torsion, and any other kind of result you want to see. Okay, so if you want to check the values on the diagram, so just check this option, show values on a diagram. So this kind of diagram will appear. This is the bending moment 33 diagram. Similarly, you can also display joints reaction. Okay, it is shown in this slide. So how you will access joint reaction forces? You just click on the display option, then go to the show forces and stresses, and from there just select joint reaction. Okay, this menu will appear, and from here you can see different joint reaction for particular load case and combination. Okay, you can also generate a report for shear force, bending moment, and different reaction in the form of tables. So for that you just go to the display option, then click on the display option. You can check different option in this data form for which you want to generate a report, right? So this kind of report can be generated in the form of table, and it can be exported in Excel format, right? Okay, with this slide, analysis of 2D frame in SAP 2000 is concluded. And now I will discuss about zooming option in SAP 2000, right? There is several option available in for zooming in SAP 2000. The first one is the rubber band zooming, and it is shown by this icon, and it is used to zoom some specific point. Fine. And the second zoom option is restore full view, and this is shown by this 2 point, and in this option you can restore full view, right? And the third one is the restore previous zoom, and this is shown by this particular icon. In this option you can restore any previous zoom. Fine. And the fourth and the fifth option is where you can zoom in one step, zoom in and zoom out, right? Okay, there is some display option also there in the SAP 2000, right? And this is the icon. You will, when you click on this icon, so this display option for active window will appear. Keep in mind this thing, the changes that you will made in this display options will be only applicable to the active window. If you want to apply these changes to all window, you click check this apply to all windows, right? Kindly go through all different options by yourself, and you will see how these display options work. Okay, assignment and lab report format that you people submit. The assignment and lab report will contain the following informations: the methods, the procedure follow for modeling and analysis, and then you will also provide final model snaps, and then analysis diagrams including the shear force, the bending moment, and other result snaps and tables if required. Fine. Okay, now I will solve some few example in SAP 2000 for your understanding. So do practice on this one, right? So I will only solve this particular one, this example, and also the example that is given at the start of the lecture. Before going to the software, first of all define a number of grid line in x and y direction, right? I am going to define two grid line in x direction at location B and at location D. I am not going to define a grid line in C location because I can draw this load at the center. Similarly, I will define two grid line in the Z direction at location A and location B. So the spacing in both grid lines will be 10 feet. Okay, first step is to create a new model. Just go to the file, then click on new model, right? Okay, then change your unit from kip inch to kip feet as per the requirement, then click on the grid only, right? So as I told you earlier that I require two grid line in the x direction, so there is no need of grid line in the y direction, and two grid line required in the z direction, and the spacing between these two grid lines are 10 feet. Okay, then change your plane from xy to xz in to make your grid line visible, right? Now next step is to define a material property. In the example, the materials are material is made of concrete, which is 4 ksi, and change material type to concrete, change unit from kip to inches, and modulus of elasticity in the example is given by 36,000, and Poisson ratio is 0.2, and specify compressive strength is 4 ksi, right? The material is defined. Next step is to define section property, that is the cross section property for both beam and column. Then go to the define, then section property, click on frame sections, click on add new property, change frame section material type from steel to the concrete, and then select rectangular, right? First of all define beam, and beam is made of concrete 4 ksi, and depth of beam is 12 cross 14, right? So the unit is in feet, so you will convert that to feet. It is 12 cross 14, so the depth is 14 divided by 12, and the width is 12 by 12, right? From the concrete reinforcement, change column design type from column to beam. Okay, now define column section, again rectangular, change it to column, select concrete 4 ksi material, and the depth of column is 14 by 12 and 14 by 12, right? And the concrete reinforcement is okay. Reinforcement configuration is a rectangular one, and clear cover I will keep the same. Okay, the number of longitudinal bar along 3 direction face is 2, and along 2 face it is also 2. Okay, the size of longitudinal bar is actually 6.1, right? Similarly, the confinement bar from the figure is 3, it is number 3 bar, right? And confinement bar in the third direction and 2 direction is 2. Okay, click on OK. So your column cross section is defined. click on OK. Now next step is to define load pattern. Just go to the load pattern. Okay, in our case all the loads are dead load, so there is no need to define any other load pattern, so keep it dead only. Then load cases, so just I want to run the dead load case, so there is no need to define load cases as well, and there is no need to define a load combination. Okay, now I am directly go to draw this 2D frame. How you will draw this 2D frame? Just go to the draw, and from this draw menu select draw frame and cable. Right, first of all you will draw a column. So from this section property, change section property from beam to column and draw this section point to point. Then for the column beam, select beam from the section and draw it. Right, now next step is to assign joints. This joint in the example is fixed one, so go to assign, then frame, then joints, then restraint, select fixed one, and the other is roller supported, so select this joint and go to assign, then joints, restraint, then select roller one. Right, and now we will apply loads. First of all I will apply this uniform distributed load applied at this on this column. So select this column, then go to assign, then frame loads. From frame load you will select distributed load. Okay, the unit in kip feet, it's okay. The direction of load is toward x direction, and the load magnitude is 20 kip per foot. Okay, so 20 kip per foot load is applied. Similarly we will apply a 150 kip load at center of this beam. Okay, for that you will select this beam, then go to assign, then frame load. Okay, from this frame load you will just go to the point load, and the direction of this point load is gravity, so it is okay. Then you will apply load at particular point. So the point in this location is a centered one, so you will apply load at centroid in the center location. So here the distance will be if you are select absolute value from from end I, so just put 5 because the total distance is 10. Right, and put the unit of the value of this load, it is 150 kip. Okay, so 150 kip load is applied. Okay, now if you want to show all the loads, just go to display, show load assignments. On joint it is already visible, so click on the frame cables. Okay, so all loads are assigned. Right, now you can run analysis. Just go to analyze, then run analysis. Just click on run now. Now save your model. Right, okay, the analysis is completed. Now you can see different results. So first of all, if you want to check the shear force and the bending moment, so go to the display and go to the show forces and stresses, then click on the frame and cables. Right, just you want to see bending moment diagram and show values on the diagram, so click OK. So this is the bending moment diagram. If you want to see the shear force diagram, so again go to the show forces and stresses, frame and cables. So from here you will check shear 2 2. So this is the shear force diagram. Right, so this is all about this particular example. Okay, now I will solve this practice example number 2 in SAP 2000. Grid line in x direction, one grid line, 2, 3, 4 and 5. I'm not going to define grid line for this particular load because you will learn in this example how to apply a load without a grid line. Okay, these are the grid line required in x direction. So you required 5 grid line in x direction, and first you will define a uniform spacing for the grid line, but later on you can edit ordinates. So the edit ordinates are given here. So first ordinate will be at 0 location, second will be 6, 10, 16 and 20. Okay, similarly grid line in the z direction, so 1, 2, 3 and 4. And again I am not going to define a grid line for the loads. Okay, in this example you will learn how to apply this particular load. Fine, and the spacing can be edited accordingly. So the grid spacing along the z direction will be 0, 7, 12 and 15. Okay, now I will solve this example in SAP2000. Okay, first of all create new model, go to the file, new model, then click on the grid only. Okay, a number of grid line required in x direction are 5, and along z direction 4 grid line are required. So first of all we will just put any spacing, later on we will edit it. And then switch from XY plane to XZ plane. Now right click on the grid lines and edit your grid lines accordingly. Okay, in our example the first grid at 0 location in X direction, second at 6 direction, 6 point, third is 10, fourth one is 16 and last one is 20. Similarly the grid spacing in the Z direction are at 0, second one is 7, third is 12 and last one is 15. Click on OK. So the grid line are edited accordingly. Now second step is to define materials property. So I am skipping this step. I am directly going to define the section properties. Just click on the frame section, add new section, then click on the rectangular. First of all I am going to define the beam cross section, and I am keeping the materials as by default, and the depth of beam is 14 and width is 12. Right, from concrete reinforcement change design time from column to beam, click on OK. Okay, then define column cross section, rectangular, it is column. Okay, the depth of column is 18 inches and width is also 18 inches. Fine, then from concrete reinforcement design type is already column, and reinforcement configuration in example is rectangular, and there is a tie. Okay, number of longitudinal bar along 3 phase is 3 in the example, and also 3 in the second direction. Okay, the longitudinal bar size is 9, it is okay. Okay, in the confinement bar the size is 3. Okay, the number of confinement bar in both direction is 2. Click on OK. So the column section is defined. Okay, again I am skipping the other steps like the defining the load pattern, the load cases and load combination. I am directly draw the 2D frame. How you will draw? Again go to click on the draw element. Okay, first of all I want to draw a column, so select column from here. Okay, where is the column section? If you can check the example, it is started from this point to this one. Okay, so it is from this point to this one. Okay, now I want to draw a beam, so select beam from here and draw your beam accordingly. Similarly, again another column is also there in the location of C. If you can check the diagram, okay, it is at location 3 and it is extended to the final grid line. Okay, again select column from this location and draw column. Okay, once the 2D frame is drawn, now we will assign different support conditions. Okay, at this location and at this location and at the last location there is a hinge supported, there is a hinge support, so we can apply directly hinge support at this location. Select all these 3 locations at a time, then go to assign, joints, restraint, and it is hinge supported, so select hinge. Okay, sorry, we have left with one column, this one. We will draw this column as well. Right, now there is a roller support at this location and fixed support at this location. Assign these supports, and this is fixed support. Select this joint and go to assign, joints, restraint, and fix. Right, now I will apply point load at this location, and it magnitude is 5 kip. How I can apply this load? So the load is at this, on this frame, so select this frame first, then go to assign, then frame load. From this frame load, click on the point load. Right, and this point load is placed at which location? It is at distance 4 feet from this location. Right, so from here you can change distances from relative to absolute and enter 4 distance, and the load at that 4 location is 5. Okay, you can see the 5 kip load is applied at the location where you want. Okay, second load is applied on this column section, and it is applied at centered, so select this section and go to assign, frame load, and point load. Right, check the direction of the load is toward X. Right, then change the direction of load from grid to X. Again it is at location 4, it is at location 4, so the distance again 4, and the load is how much? The load is 10 kip. Okay, so 10 kip load is applied at this location. Now similarly we can apply uniformly distributed load on this column. Okay, this load is applied over 10 feet distance, and the magnitude is 10 kip per foot. For that, select this column, then go to assign, then frame loads, then distributed load. Okay, from here select absolute distance. At 0 location the load is 10 kip per foot, and at 10 location, 10 feet location, the load is again 10 kip per foot, and keep the all other 3 and 4.00. Click on OK. Okay, now we will apply a uniformly distributed load on this column, right? And this uniformly distributed load is applied at a distance 10 feet, and the direction of this load is opposite to the X direction, right? How we will apply this load? Just select this frame section, then go to assign, frame loads, then go to the distributed load. Okay, first of all change the direction of the load, and it is opposite to x direction, so you will put negative sign, and then go to the trapezoidal load option. So at distance 0 the load is 10, and distance 10 the load will be also 10. So for that you will click negative sign for the opposite direction, click on OK, right? So the 10 feet load is applied on 10 feet distance, right? So now we are in position to run analysis. Just click on the run analysis, or just press F5, and here you can set different load cases to run, and just click on run now. Okay, when you click on the run now, you just save your this example. The analysis is completed. Now you can check different results. Again, go to the display and shear forces and stresses cable. From here you can see bending moment diagram and shear force diagram, right? So for the bending moment diagram, check M33, click on OK. So this is the bending moment diagram, right? If you want to check the support condition, support reactions, so again go to this display and show forces and stresses, click on the joints. So from here you can check, you can display the different support reactions, right? So okay, this is all about example number 2. Okay, this is practice number 3. Kindly do this practice by yourself. And this is all about lecture number 5. Thank you so much.